So thank you everyone for joining me today. I apologize if I'm a little out of it. Something didn't set well with me last night, and I've been up all night. So we're going to see how this goes. First run through, and I've been up all night. Should be interesting. My name is Kellyn Gorman. I'm a senior cloud solution architect. I am a subject matter expert for Oracle and Azure at Microsoft. Yes, those do exist. I know you're all going, no, no. And so I was sitting here squirming while Steve and Stephanie were talking about Oracle and Microsoft and all these other things. I am doing Oracle on Microsoft Azure. So it's a weird scenario. I'm very, very busy. I have migrated 170 customers, over 170 customers in the last 18 months over to Azure. And it's been a wild ride, but that means that I'm doing infrastructure as a service. What that also means is I have control issues. And I think the best DBAs do. This means that we want to make sure that our databases are running as optimally as possible for our customers. And we know that you can only throw so much hardware at a software problem. So I'm all about this. And it's just kind of where I go. And as much as we want to say why we go to infrastructure as a service is because it's a choice, it's also a lot of other things. We have SLAs that may say that we need to be an infrastructure as a service going out by policies and that from our companies. Maybe vendor-specific requirements, just as I work within Oracle on Azure. Oracle itself isn't a PaaS solution within Azure, so of course I'm kind of in that scenario. But you may have a SQL Server version that you're required to by the vendor to have, so you may not be able to go to a PaaS solution. And you know, it's just these different situations. And like I said, I just have some customers that are like, you know, we're going all infrastructure as a service, our first time into cloud. So this is where we lie within the cloud's, realm. You have your on-premises systems. You have your infrastructure as a service, which I don't know if you can see it as clearly because it's like in grays and different shades of gray. But that whole idea of what you're responsible for. On-premise, you're responsible for everything. And I know this is a review for some of you that are going, I already know this. But infrastructure as a service, we're taking care of the applications, the data, the runtime, the middleware, the OS, and then the actual servers themselves along with the storage and the networking and the virtualization is being taken care of by that cloud provider. And then you have platform as a service, which is one more step up, which means that we're only responsible for the applications and that data, and the software as a service where we make them manage everything. So what are some of the benefits of it? As I said, you have more control over it. For my customers, many times we're looking at Oracle and there's this, we feel this pressure, this mass exodus from some of the older archaic relational databases, and they want to refactor everything. There may be dependencies on PL SQL, regular expressions and that written into those Oracle databases, or again, vendor requirements that need to take a little bit more time. And it can be 2 to 4 years for them to refactor an application and put it into a different database platform. With infrastructure as a service, I can lift and shift that in a matter of 2 months, 3 months. It's a much shorter deadline for me to lift and shift it. There's other ones that say, I just want a similar architecture. My server monkeys, I'm going to say that. My infrastructure as a service people are going to feel more comfortable if they know that they're able to manage this and their jobs continue. Your DBAs continue on very often the way that they did before. It introduces cloud services and features that you wouldn't have had available when you were on-prem, and that helps you evolve. I call it the lift, shift, evolve message that I'm always talking about, that we could introduce a data lake, or we could introduce Power BI, and analytics features and things like that, that they wouldn't have available to them or wouldn't be able to use as efficiently if it was still on-prem. And it also removes that data center. A lot of people are getting rid of their data center, and we'll talk about that a little bit more, but just that hardware that they're purchasing and they have to maintain and they have to budget for, and that, it's a lot. It's a lot, and the overall cost of it starts to look pretty steep. So this is what I deal with day in and day out. You may have heard this in different ways, but I'm hearing this from the infrastructure folks. When you are a database administrator working in infrastructure as a service and they're trying to lift and shift this to the cloud, you're going to end up with an infrastructure person. The infrastructure person is going to continually try to lift and shift that hardware, and it doesn't work so well. That was the reason that some of the initiatives that I built out at Azure has made such a difference. and our ability to lift and shift Oracle environments into Azure is that we weren't lifting and shifting the hardware. We were lifting and shifting the workload. And what that means is that we're finding out exactly what the database needs. And my best analogy of this is if you have a 5-year-old child and you're trying to build them clothes or buy them clothes that will fit them when they're 10 years old, you have no idea how much they're going to grow, how they're going to grow, and if it will actually fit them when they're 10. So when we're buying servers that way, we can have servers that have way too much CPU, not enough I/O, too much memory, not enough memory, all these different scenarios that, especially when we start talking about products that are licensed by core, by our CPU, that could be very impacting to the underlying cost. As much as we want to say, oh, well, servers cost a lot and cloud costs a lot, for Oracle scenarios, it's often the licensing. So that I'm able to identify that workload and find out how much memory and CPU, especially, as well as I/O that is required, I am able to size out exactly what they need in the cloud today with the ability to scale up as new modules and new products come out and new features and upgrades, that they will then scale up at that time. And so they're going to make better use of their licensing that they have now. And when they actually renew their licensing, just update what they need. For different databases, there are different tools to do this. I know I specialize more in Oracle, but I have done this for SQL Server, Azure SQL. I've done this for Postgres as well because Oracle Postgres story is a big deal for us. The ability to utilize these tools as well as scripts. For Oracle, it is definitely the AWR when I am sizing out an environment. There are other tools that you can use to kind of look at some of this data. You know, we can query the ASH. SaaS, for those of you that aren't licensed for ASH, I won't tell anyone. StatsPack for those that say, I know I'm not licensed, I'm going to use it, do it legally. As well as tracing when we're looking at performance issues and finding out exactly what's going on underneath the covers. MySQL, we've got SolarWinds, DPA, Instrumental, Panopta. These are all tools that help us with the MySQL story. SQL Server, Dynamic Management Views, Perfmon. Perfmon is very powerful on that side. Scripting, I like Paul Randall and David Clay. I was just talking to him with some of this Perfmon scripting, really cool stuff. And then, of course, Redgate SQL Monitor. That ability to gather that information, know what you're working with, and you're not making assumptions. It is hard enough when somebody says, this is what I have on the server, and I'm going to lift it and shift it. If you don't have that information behind you to have an intelligent conversation with those infrastructure people and size it out appropriately means you can set yourself up for failure. You are assuming, you are guessing, and I don't believe in that. So gathering up that information to find out what you actually need will serve you later in the end to creating a successful situation when you migrate to the cloud. So architecting to the cloud, one of the big deals is move it all to the cloud. Try not to keep half of it on-prem. Egress and ingress charges can be phenomenal, especially when people have been architecting on-prem for so long and didn't need to worry about how much they were pulling back and forth. It can be a real headache. So I always recommend just move it up to the cloud even to start. Reduce that latency. Optimize before you move to the cloud. I think it's so easy to say we're going to lift, shift, upgrade, and we'll optimize afterwards. Everybody wants to put off tomorrow what they could do today. It could really impact you. So take the time to run through a complete optimization exercise of that database to identify what red flags are there. If you have any upgrading to do, upgrade before you go to the cloud. Don't do it afterwards because it can heavily impact your migration. As people try to figure out, well, was it Azure that caused this problem? Was it the upgrade that caused this problem? Was this optimization that caused it? Put those into little bite-sized chunks, address them each in their own individual project before you actually migrate to the cloud, or after if you decide to upgrade after you go to the cloud. Refactor these large processes. Again, because people have designed their code to work on-prem, and they've been designing this whole time with that idea of this is how I work. In the cloud, they may not do it the same way. They may grab all the data down into their application and then throw away everything other than what they need. You may say, you know what, we're going to actually fix this way up in the cloud, parse through all the data, and only bring back what you need. That idea of working efficiently in the cloud is important because then you're not creating latency within network connections across your express route, which you hopefully have if you're bringing stuff back from the cloud to your on-prem, as well as doing things efficiently across the I/O and the CPU and resource usage. Lift and shift is also not equal to lift and shift exactly what you have. We see customers many times using archaic processes that it wasn't broke, they didn't fix it. But it may not be what you want to lift and shift into the cloud. We have a lot of customers, with Oracle that look at RAC. I know all of you on the Microsoft side have heard the glories of RAC, but RAC to me is an oversold solution. It is a unique solution for a problem that not everything fits. And so it's important to me to take a look at those processes, find out what latency is created by what we call a global cache, which is shipping that information back and forth between the nodes, and find out, is that really the right solution? Because about 99% of the time it isn't. And I would rather implement something like Oracle Data Guard, which is very similar to always on availability groups. It makes sense for the cloud. We already have that redundancy built in with the cloud. When we start talking about how many times data is copied over, are we really going to have a data center outage? Are we really going to have outages between, if we build in availability sets and availability zones? No. We are now architecting for the cloud. We're not architecting for on-prem anymore. So we want to make those smart decisions. Some of the older backup technologies can also be very heavy on the I/O. Do we really want to bring those into the cloud versus taking newer technologies such as snapshots that are going to be much more efficient, going to be faster in the recovery, create less impact to that resource usage, that redundancy? So let's talk about our VMs a little bit. This is where the DBA needs to know a little bit more about infrastructure. Anytime you have a problem, they're going to throw an infrastructure guy at you. So it's important that you know what you're dealing with. I think these numbers and all of these series and tiers of support and storage that are available to you can be really mind-numbing. So taking it apart a little bit is extremely important. Yes, you do have A and B series on the VMs. No, you shouldn't be using them for databases. They don't really have the memory. They really don't have the CPU. And even if they do, they don't have the I/O capabilities that you would want to use them for a database. We'll talk a little bit more about I/Os and VMs specifically, but later as we go along. But keep in mind that D series might work for some of your smaller SQL servers. It's not very possible for most Oracle workloads, but some SQL servers might, maybe a couple little baby Oracle databases, but not very often. L and H look interesting, but when you start looking at those workload, if you know what resources you need in CPU, I/O, as well as memory, you'll find the combinations that are available in L and H very rarely match anything that you're going to need in these database servers. After you've identified those workloads, you're going to look for D series, maybe for a couple general use or maybe development, but you're going to stay most of the time in the E and the M series. E series for most database workloads. Enterprise usage, we're going to get into those M series, those memory usage, especially for Oracle. These go up pretty high. I mean, when we start talking about, there are 416 vCPU machines. Yes, I have a customer using 416 vCPU and 17 terabytes of memory. They are out there. They are doing this. Yes, it is Oracle. I'm sorry, it is. But this is true. And this is how we address customers that say, I need to be able to scale. And to scale, I introduce RAC. And I'm like, I got a VM for you. That's extremely important, that as we add more power, that we're able to address that for them. And of course, my first choice is to always optimize that workload to try to bring them down. I don't want them always up at that upper echelon of what we have to offer. I want to make sure that they have a long-term satisfaction with Azure. So my first bet, and I think anybody who's a DBA knows this, that you can throw hardware at it, and yes, you probably solved it for another 6 months before it shows up again. Natural life of the database's growth. But if I actually optimize that SQL, I can do it for the long term, and they're not going to be back at my desk in 6 months. So keep that in mind. Always look at optimizing first, throw iron at it second. That should always be your solution for this. But the M series are incredibly powerful systems, and you're able to size up for whatever you need. Now, when we start talking about this, a lot of people don't realize that Oracle workloads do run on Azure. As I said, I myself have migrated over 170 customers. I picked up another 7 customers this week. It's constant. It is constant coming in. And we realize how important many of these customers are dealing with, that they want to go to Azure, that they need a viable workload in cloud, and that more customers are changing every day going to the cloud. Where before, especially before even the pandemic, they were thinking about it. Now it's gone full steam. I feel this. I've always been pretty much Azure. In the last 2 years, I've been Microsoft, but it's really picked up steam, and these are monstrous. Another thing is the network. The network is our last bottleneck, and I will mention the 30 gigs per second on the Ethernet is incredibly important, along with the 200 gigs per second on the InfiniBand. InfiniBand is something that most Oracle DBAs have really fallen to, and were really important in the engineered systems. So knowing that it is there in the backbone of our Azure cloud is crucial, of making sure that you have fast interconnectivity between your VMs. So the opposite end of that spectrum is when a VM is too much. We have this with Oracle, we even see it with Exadatas. You have that one database that was thrown on there for a reason. They bought the Exadata for a reason, and then they consolidated everything else out there. But you may have databases that just don't need a full VM. There's something called constrained vCPUs. You will see these. They're extremely powerful, but you can break them down and allocate what you need to each database. Oracle has just started supporting these, and I love them for this. This has made my life so much easier, especially when I'm doing data center moves, because like I said, you may have a couple big whales in the pond, but you also have a number of databases that are smaller, and the shared storage between them, they're monstrous. So I'm able to actually go through those and allocate out what needs to be allocated to, and then I can find striped disk and storage accounts that will match out and share among the databases so that they are able to make the most out of that I/O. The way that you're going to see these, if you look in the pricing calculator, you're not going to find them, but I did put a link in the bottom of my slides if you're interested in looking at them. And the way that these names are, notice that the name of them is how much vCPU, and then you see that 2MS, that's the minimum vCPU you can allocate. So the minimum vCPU would be 2 for that first one, the standard M8 2MS. But if you looked at it on the pricing calculator, you would see it under the M8 MS. It's the same machine, same price, whole works, but it's constrained. So if I have a customer that says, I have 4 databases, they each need only 2 vCPU each. We've already calculated the workload. What do you got? And they need high memory usage. I would be able to allocate this machine. And there's all different calculations. There's a lot more than what you see here. I just grabbed a section of them and threw them up. But if you go to that link, you can see all of them. There are tons of these. And they really come in handy, especially if you're doing that, like I said, a data center consolidation, because you can just grab and take what you need and just kind of divvy up those databases into different servers and consolidate and take advantage of what you need within that cloud. So let's talk a little bit about 24/7. We all worry about HA. We all worry about DR and all of these things, as well as our RPO or RTO, which we'll talk about. On the Oracle side, we hear a lot about maximum availability architecture. And one of the things that people will say over and over again is that means rack, and it actually doesn't. For those of you that aren't familiar with rack and that it is the end-all be-all of the Oracle world, is that rack doesn't actually meet the requirements for most high availability. What it meets is the high availability demands for most DBAs. We have rolling patches. We have the ability to do rolling upgrades, and we don't have to worry about having the database down while we do our maintenance. So it's really crucial to us. We like that for that reason. But with this, we're able to bring in Oracle Data Guard. Since 12c, they've got new features in it that allows us to do those same things. We can do fast start failover, which like availability, always on availability groups, gives us the ability to give that uptime that people want for databases, not having to take them down all the time, be able to those sessions, those customers don't feel that outages as well, those users. We want to make sure of that as well. So it's different names under different platforms in that. I, of course, recognize it under MAA or maximum availability architecture. The most important thing to find out when somebody says that they need this or they must have HA and they're asking for something very, very specific and they ask for it by name is find out what their SLA uptimes are. Ask them what they are trying to achieve and document that. And then you can fit the solution to it. There's a lot of solutions within the cloud that we're about to talk about that will solve those. The on-prem data centers, they're not the same as the cloud architecture. So make sure that you've geared that customer when you're talking to them, when you're actually working with them, when you're actually moving your database systems there, that you're gearing it towards the solutions that are available in the cloud, not trying to reproduce what you have just on-prem. And add other products and services. As I was talking about, we're going to talk a little bit about availability sets and availability zones and regions. I think everybody's got regions stuck in their head, and there's some changes coming up that might help you if you're starting to look at the cloud. And again, find out what HA means to those stakeholders and find out who the stakeholders are. Again, I'm going to be talking to DBAs a lot, and DBAs will tell me, I need RAC, I've got Oracle, I need RAC. And you find out they're not really the ones making the decisions. And so I need to pivot. Find out that, it's the right decision. I'm going to match what I need to the infrastructure as a service hardware that I'm building it onto. I'm going to try not to introduce any overhead. RAC is pretty costly on the resources. It's got to ship all that information back and forth between the nodes. And does it have vendor support? That's another important thing. As you're working with your product, make sure that it has third-party support in the cloud. And then look at those services that are available to actually duplicate that and meet those requirements and go with that. So the first thing we need to understand is all these different concepts in the cloud between region, geography, which of course is a location, an actual area that somebody is on the planet, versus the availability zones. Availability zones is really important when you start getting into availability sets and availability zones. And understand those availability zones, those are physical regions located within a region. Those are multiple data centers. We are getting to the point with the cloud that you have multiple data centers within a region. So you're hearing East US and East US 2, and that each one of those East US have multiple data centers within those. So keep that in mind, that it's not just one data center, that there's multiple data centers, and know what's available in your region when you're starting to look at that in an availability zone as well as a region. Geo-region is a common discussion point that I hear from people that say, I must be geolocated among multiple regions. And you find out that that's probably not the best choice for them. And then secondary regions, they go, I need to have an environment in a secondary region. There are changes coming in January 2021 where there will be ingress and egress charges across regions. They want people to start taking advantage of these data centers that are in one availability zone. Because of that, we want to start talking about this early on as people are migrating to the cloud, as people are maturing their cloud environments, to make sure that they are utilizing the right solutions for their HA solution. So an availability set, this is an example here. And with SQL, of course, this is going to be awesome because you're going to have multiple availability sets. You'll have subsets that are available within a virtual network that you're able to get to. And if there is an outage, it'll be able to back to the availability set that is available. These are something that is available within Azure SQL. This is something that you can use within the managed instance, and it's all available within your on-premises network to your cloud environment. Availability zones and regions are a little bit different. Now, the diagram you're seeing here is how I diagram out an Oracle environment with multi-region and multiple availability set deployments. So that means that you're seeing my primary Oracle database with DataGuard, my primary database. I have a secondary database that is sitting in a secondary availability zone. I have another availability zone along with my Oracle Enterprise Manager, and it's not just sitting in a second availability zone, that could be in a separate region. And that's extremely important to understand, that depending on what my customers require, I'm going to build that out. And it's something you need to talk to your actual business users as well as IT organization as you're doing these migrations, to understand what you need and how to have the redundancy built in that covers your requirements for HA as well as DR. So using availability zones, make sure that, one, you have all of these features in your region that you're at. I did put a link in here so that you can click on them and take a look at the services. Single VM, yeah, you still have 99.9 with premium storage available here on the uptime. Data center, same thing. I mean, it's not like, you're on premise data center, where you're building everything out. There's incredible redundancy where data, and we'll talk a little bit about ZRS and LRS and everything here in a minute, but that you have all of this data written to multiple disks depending on how you deploy it. And then you can have the availability zones that fail over when there's a problem. and that you can also have regional pairs that are available if there's problems within your network and your data centers and your regions. So keep this all in mind as you're building this out and how much redundancy you need to be building in. Of course, the more redundancy you built in, of course, has more cost too. There's always a cost to all of this. So do what you need to meet your requirements and your SLAs, and that as a DBA, of course, your CYA, you want to know that you're able to recover, that you're able to stay up and running, and that nobody is calling you and saying they can't reach the database. But take that time to understand each one of these terminologies and technologies and understand that you may use one and two of these. You may not use all of these. You may use, the first, the availability set, and not geo-region. And you need to find out exactly what is required for your SLAs as well as your HA and DR requirements. And then here is another environment for a customer that I built out where they had their primary and their secondary in an availability zone, and then another one that was in a geo-region. They also had, by their SLAs, had to have another DR environment that was in a complete different region on the other side of the planet. This was an enterprise level environment, and we also had to deploy their Azure NetApp Files capacity pool for their third region in a different place. So you always have to document this out, and it's almost a one-for-one depending on these discussions that we have with people, finding out what they need and making sure we're building them out. Nice thing is I always build out the Oracle Enterprise Manager too to simplify the management for those moving to the cloud. And we'll actually discuss that too as we go forward. So this is where we get into DR. Oracle Data Guard and always on availability groups really do solve a lot of those solutions for you. They give you that DR as a DBA. You can bring back the database and fail over to a database, and that's all that kind of matters to us. But knowing what's going on and where the copies of the data for your managed disks are going is extremely important. So we'll talk about AZ, AG, but then we'll talk about DR products. As we talked about the always on availability groups, Oracle Data Guard, how to implement automation features to remove manual intervention. Anytime you can automate something, do it. Don't have it just tell you it's out, you have an outage. The last thing you want to do is be reactive. You want to be proactive and have it do it for you. And then just report to you that there was an outage, but you don't know about it. It was completely transparent to the user. Clearly identify that recovery point objective as well as the RTO, and ensure that your HR and DR backup and recovery decisions meet these and have been fully tested. One of the customers that I'm going to do a use case on in this next session that I'm doing for the PaaS VCC DevOps group, it was really interesting that they were like, oh, we'll test backups later, we'll test recovery later, and found out that it was the big roadblock to them being profitable as well as them meeting their deadlines, because they hadn't taken into consideration the I/O demands for the data refreshes from logical exports and imports. It is important to have your entire scenario identified, work through it, test it. Don't leave something till the end to think it's not important, because it might be the one thing that is. So storage is separate. You pick out a VM, and then you pick out your actual managed disk and your storage disk and what you're going to use for your array, et cetera, et cetera. And you need to know your I/O workload. I/O workloads are very easy to identify within Oracle, unless you're on an engineered system Exadata, and then I have to do all kinds of numerical calculations. But that megabytes per second in the I/O, they're very different. And knowing what your database is doing in each is extremely crucial. Oracle has demonstrated, on average, it's much higher than I'm seeing in MS SQL, MySQL, PostgreSQL, unless it's SAP. Then SAP is just, it slaughters a system. I'll just let you know. And as it's separate, you also have some separate limitations on the VM. So we'll talk about that as well. I think that's really crucial as we start working through this. So what is that database to be used for? That's one of those questions that you have to ask right from the get-go. Is this an OLAP system? Is it OLTP? Are we doing big data? Do we have a data lake here? Is it logging? Is it backup? We need to ensure that these have different requirements. They cache differently, cache differences that may be needed on this, and ensure that we separate those disk needs out. How we write these to these disks, especially now that many of us are going into a Linux world. I've always been in a Linux world with Oracle, but even with SQL Server, that we are creating these disks correctly. For the Oracle people, they like to use ASM. And with ASM, we found out they weren't creating the actual volumes, striping and mirroring correctly. And if we didn't see those commands, all we could tell that it was sequentially reading or writing to a disk after disk after disk. It would fill up the disk, go to the next one, go to the next one. It wasn't mirroring across and writing to all of them at once. And you would realize that somebody did something wrong and you'd have to start over. These are painful reminders of how important it is for IaaS DBAs to know what they're doing with the hardware, not just the database. You need to know the differences in storage, the actual general purpose V1 versus V2, your blob storage. Your blob storage is really great for backups. Would you ever put a database there? No, you couldn't. It's just not even an option. File storage, same thing. V2 for your data lakes. Data lake usage is very different than a relational database. So we need to keep that in mind as well. Most database workloads are going to go on premium. Regular disk can't handle the I/O demands. The megabytes per second is just too much for it. So keep that in mind. And I do have a link down to premium storage performance so you can understand that. Again, premium storage, that I/Os, keep in mind that we will go over the limitations per VM on I/O, the bottleneck that's there. I/O throttling is a big deal for database servers, and it'll be the most common reason that you're sized up on a VM, is what I find. So this is what we were talking about. This is a table that tells you the services that are used for that. Supported tiers. Like I said, standard, you're not going to be using very often. You're going to be using premium. Premium is extremely important for us on the database world. Access support, hot, cool, archive. These ones are all the same. When you start talking about blob storage, file storage, you're not using those. You're in the GP, general purpose V2, is where you're spending most of your time. Replication, and we will talk about LRS, GRS, RAGRS. These are extremely important as how we work with these and what benefits they offer you by how often and how many copies they make of your data to other disks when they write to you the primary disk. So this is the premium SSD size and limitations, and this is what we're going to talk about here with I/O throttling. So you can see that many of these P1, the actual capacity, 4 gigs, you're like, that's a tiny disk. I'm never going to use that. But let's say your logs, your transaction logs, your redo logs, you need a place to put those. You're going to want a certain write cache that's going to be turned on there. You're not going to want to have, for your data files, you're going to want to have just read cache put on. But you may want read and write cache to this, and you want these written down because you don't want what we call write-through cache, because we want it to write through to the disk. Otherwise, it could be a concern, especially for Oracle, for database corruption. We need to have our actual logs written to the disk immediately. We don't want it cached. We don't want it just in memory. We want it actually on the disk itself. So this might be a good disk to just put our logs up. We don't want it in the same place that we're going to have our data as well. There's a lot of competition for I/O on this. We're going to want to have these separated out. So the small disks have their reason. The other thing that we're going to look at is as we look at some of these larger disks, but not monsters. I think it's easy to say, I'm going to get a P70 disk. I'm going to have, 16 terabytes and I'm good and just allocate this all. You may not get the performance you need. Old-fashioned Linux striping and mirroring of disks really has a benefit in this world. And being able to write to multiple disks will give you better I/O performance. Now, notice the cache limit per disk. Caching will only go up to 4 TIB. That's it. That's the max it will do. So even though these disks are larger, you may stop on the allocation at 4 terabytes. So why would you go up to anything over P50? And even that P50, remember, you're going to let that last gig just go. You're going to say, I'm going to allocate on that volume 4,095 gigs, and I'm done. I'm done. I'm not going to go any bit farther, because if you go over that 4,095, it's going to shut off the caching. It will do it by default. So all of a sudden you lost your caching capability and your performance is going to slow considerably. You want that read caching. You need that read caching for good performance. So keep that in mind as you're looking at this table, that even though these large disk sizes may look very optimal for the use and go, oh, yeah, I can get all this size for this small price, it's probably not what you want. The disk throughput, megabytes. This is another thing that is a little misleading. We can say that we get so many megs per second for this disk, but there's an I/O limit per VM. And we'll talk a little bit. I'm going to save that. We're going to talk about it in a little bit here because it is a concern. And we'll go on to UltraDisk because this is what Infra is going to send you every single time. We're going to up it to UltraDisk. UltraDisk, we don't use that often. They don't have a lot of benefit. It's not available in all regions and not available to all series of the VMs. It isn't even supported unless you have 12.2 or above on Oracle. I have a lot of 12.1 databases. It has limited reasons for it. So logging, love it for logging. Love it for redo logs. I love to put those there. But for the main databases, there's some limitations on it. And again, you're seeing that throughput per disk looks really awesome. But that's when we get into our IO throttling and all the other stuff. Redundancy. This is where you were seeing that LRS and ZRS and GRS. This is what they stand for, locally redundant storage. It copies your data synchronously 3 times within a single physical location in the same region. It's not considered HA, though, because it's in the same region, in the same data center. That's not going to be HA. If the data center goes down, you lose your data. Zone redundant copies it in first 2 and then third in a secondary region. That's HA. So as we start talking about having rack or other HA solutions, keep in mind that if you choose these, that these are available on your disk and you've configured these, you're building out your HA behind this. So all of these have to be taken into consideration as you have your high availability solutions built out. That we have, ZRS or we have GRS or we have GZRS. If you have only LRS, then we need to talk about your database and how nervous you feel. Geo-redundant storage copies the data synchronously in a single physical location of the primary region on LRS, then copies data async to a physical location in a secondary region. So you get those 2 copies. And then GeoZone redundant copies the data synchronously against 3 Azure AZ in primary, and then another one in a secondary region. That is the top notch. For my customers that have very strict HA requirements, they will usually go for GeoZone redundant storage. Now, the limitations there is that if a customer is testing their DR, they need to verify that they can fail over, that it's available in their regions, and that they're able to fail over to their region and attach it to a new database server to recover from. These are some of those things that we have to go through as we part of these DR recovery and scenarios for the projects. And here's our answer, IO throttling. IO throttling means is that if you have a VM in a cloud solution, we can't give you everything. We have to make sure that there's no noisy neighbors. And so you may be throttled if you're trying to take everything, all the megabytes per second. So because of that, there are max cache intent storage throughput for IOPS and megabytes on every VM. And this may be the reason that you are told by infrastructure to size up. Even though you have 16 vCPU and 437 gigs of memory, you may only be able to get 200 megs per second. And let's say your database is, 400 megs per second. They're going to push you up to the M32 TS. Keep that in mind that even if your disk says you can do 700 megs per second, your VM may throttle you back. And I will also tell you that Premier Support, if you open a Premier Support ticket, there is a tool there that we can't share with you, but that can show us the IO throttling. And I use that myself when I'm trying to troubleshoot a problem. And it just quickly isolates that I am outside of the database. When I see that flat line happening in that database usage, I can go to that and look and say, yes, throttling occurred. And this is what we're up against. And this is our series. And this is our disk. And that's why you're not getting what you think you are. And I have to just tell the customer that, and they have to trust me that that's what I saw because I can't share it with them. So these are the things that you need to think about, and all part of that combination when you're going to the cloud. So bring in additional solutions. There are a number of them. ANF is Azure NetApp Files for our Exadata loads, which are monstrous machines that to the Microsoft people, it's kind of Azure DW used to be. Azure DW is now part of Synapse, the data pools. That's kind of the love child between Oracle Exadata and Azure. You have the ability to offload to secondary database nodes or secondary nodes. It works kind of the same thing. They have cell nodes that they can offload work to. And you have your primary database nodes, and there's all intelligence built into it. You got this massive parallel processing, very similar on the Exadata side. They have indexes that are in memory. They have, Flash that is used towards logging. They have Flash that's used towards pinned objects, all of this stuff that you can do when you start thinking about this. I can kind of decouple that database from the engineered system and build it out and use something called Azure NetApp files. Azure NetApp files has capacity pools that you can build out. They're not subject to that VM IO throttling. They're able to bypass that and build it onto kind of almost like an array that you would be able to share it. And I'm just using layman's terms. There's, of course, other terms when A&F we're talking about it in detail. But understand that it allows you to get better IO and performance that you could never get outside of that. Pure Storage is coming up in the realm with another solution very similar to that. And then the other deal that is really nice about this is that you can take snapshots. And snapshots is a really big deal when we're talking about how to offload some of the IO that may be happening in the database because of backups, because of imports and exports. As I was saying, that can be a real big, heavy load on this database. And, if we start talking about refactoring some of this processing, if we have somebody that says, I need to do data refreshes, and the Golden Gate process is too heavy on the Oracle database, I may say, let's see about Azure Data Factory and put some of it on a cloud service. Let's use Databricks. There's so many different solutions, and you just got to think outside the box and find the right cloud service that'll solve this. For my customers that aren't looking to do A&F, or it's outside of their range of what they're trying to do, I may bring in, it's just their backups, let's say, that's causing the roadblock. I may introduce Commvault. Commvault has the ability to offload, again, some of that workload from the database on a proxy server and produce those backups. So these solutions are out there. You just need to do a little bit of research, and the solutions will help you along and get you where you need to be so you can have the performance and long-term satisfaction on it. Available in the premium storage, we start talking about cache settings. This is another thing of where you're actually caching in your storage itself. It's called AK blob cache. It's default to read or write, which you don't want in your database. First thing you do, shut that off. You don't want read or write. You want read only. Read is really good because that's right through caching. The writes still go because it can corrupt your database. It is a concern. It's a small concern, but it's still a concern. And as a DBA, we don't like risks. As I stated, it's 4,095. It should say, yep, it says there, Git. You can't go over that. And so anything above a P40 disk, you're going to run into this. P50 is 4,096. So that last 10 on there, I'm just going to ignore. I'm going to take that as a loss and go forward if I'm going to allocate that, because otherwise by default, it's going to shut off the caching and you're going to lose that capability, that performance that is really crucial. We may, to allocate that amount of space, we're going to mirror disks, we're going to stripe disks, we're going to use more smaller disks so that we can have that caching and get the space that they need, the actual storage space that they need. So keep that in mind. This is only available on the M series, and for the other ones, like there's a few in the E series, and I don't know if there's any in the D series or not. You'd have to look at it. I do have some links on that other page where you can look at it. But find out and make sure you have the caching, because that makes a crucial difference in how the performance will be. If those blocks that are utilized often are cached, you're going to get a better response time. So depending on the combination of storage and striping array, it can really vary. You want to make sure that you're striping correctly. You want to make sure that when they are creating those disks, let's say you have an infrastructure team that's actually doing it, that they document what commands they used. It's not something that you can go back and find. You need to make sure that they are actually striped correctly, that they were mirrored correctly, that you're getting the performance. You need to be able to go in and make sure that the caching is turned on. These are things from a DBA perspective that you will want to know. There's a lot of documentation out there to assist you. If you go out there on Microsoft's pages, Azure's site for their documentation, they're going to be able to tell you that. In Linux, consider huge pages. Huge pages are a huge benefit for any database. And then we often use the LVM, which is the Linux Volume Manager over the Oracle ASM. Oracle ASM was really great on-prem because it allowed us to bypass that secondary volume manager, and we had more control over it. The one benefit is that we can continue to add to a volume versus creating a secondary volume. But even that, there isn't a real performance benefit to it. It's more of an ease of management. And keep the eye on the sector size too. And I didn't finish out the sentence. I see I need to fix that in my slides. There's a 512K sector size, and if you're under Oracle 12.1, you're going to run into issues with it. So depending on some of your Oracle releases or database releases, you need to look at that definitely and make sure that you can simulate, the 4,000K sector size. So you can do that too. And then we start talking about the failure due to backups. Backups can be very resource heavy, the IOs and that. So really consider using snapshot technology, use the profiler, or actually use perfmon. Don't use profiler, but find out what that workload is, find out what that impact is, and go out there and identify that IO and see how much it's going to add to your database. If it throws you over that IO throttling limit, you're going to get hit. And it's going to impact everyone. It's going to impact your batch loads. It's going to impact anything that's going on in the database at that time is really going to be impacted, and it's going to go across the board. It is non-discriminatory. It doesn't say that resource metrics say that you're going to get the first dibs on the IO and the backup's going to wait. No, it doesn't happen that way. Everything's going to be impacted. So keep that in mind as you're identifying some of these areas to optimize that your backup and your strategy for refreshing data needs to be taken into consideration. You may want to look at actual snapshot technology for that. And simplify it. Use your tools that you already have. For us in the Oracle world, it's Oracle Enterprise Manager. It's Cloud Control we'll put out there. Use those features to automate patching. I simulate a PaaS solution. And there's other ones that are out there that can help you out. I was very impressed with the actual, I'm just going to use it even though I'm in Redgate here, the SolarWinds capability in the cloud. I'm hoping that Redgate will have one too soon. But the ability it deploys a VM, allows them to have a management console there. And keep in mind, I would expect that Redgate, we could probably do that with theirs too, their SQL Monitor. And that way you have a similar tool that you're utilizing to manage your databases that you have already on-prem. Don't make it harder for you than it needs to be. Utilize the tools you already know. The scripts that you already have, utilize those in the cloud too. Most of them are quite transferable. So that'll make life a lot easier for you. And if you're new to Linux or you don't want to manage your Linux, there's a brand new feature that is just about to go GA that is automating your OS patching. The automated patching service from Azure is awesome, and that way you don't have to do that. You don't have to remember to do that. It just makes life really easy and makes it more of what I call simulating a PaaS solution inside infrastructure as a service. So keep in mind, it's not just the infrastructure. You are dealing with a database that if you are going to release or actually submit a ticket through Azure, they're probably going to look at the infrastructure only. We've ran into that being part of Microsoft. I know that infrastructure people try to fix the database load issues, not even looking at the database itself, and they just want to up the actual series of the VM, or they want to, put in a faster storage, not realizing that many times we need to look at the database load and identify what was going on at that time and maybe resolve that first. So always keep that in mind. Always keep that in mind that you as the DBA have a lot of power in this and that you can fix a lot of these problems that people may be running into that the infra people won't have any idea about. They're counting on you to do this. And use the cloud services that you already have, that you're already using it on-prem. So if you're using Commvault, bring over Commvault. If you're already using Redgate, use Redgate. If whatever you're already using, see if there's a cloud version of it and deploy that and use it again so that you're not having to relearn everything. It's more baby steps. Going to the cloud can be a bigger challenge than most people need it to be. I myself am still using the same scripts that I used on-prem. Just minor changes. I had to learn AZ commands. That was about it. It made my life very, very easy. So keep that in mind when you're doing that. And we already talked about simulating PaaS in there. So I'm going to go on to the final one here because I know we're running out of time. Know your infrastructure. Really learn the infrastructure that you would be moving to in the cloud. PaaS solutions, you don't have to worry about that. But for infrastructure and the service, you need to know about VM series. You need to know about storage accounts. You need to know about those products that are available that can be plugged in to the infrastructure as a service. You need to know how to deploy your tools out there so that you can utilize them and keep your life sane. Know the cause of the problem. Don't assume, don't guess. There'll be too many other people doing that for you. So keep yourself from getting into trouble and know what's going on. So utilize the tools you already have that can identify that. And if you don't, take some time to find that out. And just make it easier. Don't make it hard, because infrastructure as a service is an incredibly powerful cloud solution, especially for those that are just entering the cloud world. You may have new projects that you can, solve with PaaS solutions, but for many databases that are already on-prem, to move them to the cloud, you need to know a little bit more about the infrastructure that's there. And it's not just saying, oh, we'll just put it all in the cloud and we won't have to worry about it anymore. As a DBA, you have a lot to offer here. And with that, that leaves us 6 minutes for questions.
Wow, fantastic job, Kellyn. I don't see anything posted directly, but that
I did my job.
Yeah, you did your job. You did. You did everything you needed to do. Let me ask you this while we got this here. You've done mostly an Oracle person your whole life, but you've done this stuff in Azure now. What do you think about the tooling with SQL Server, with Azure, with Microsoft versus what we've had with Oracle? Do you think, is Oracle going to improve a lot? Have you seen it improve a lot? Are you happy with what's there? I only say this because I've been using SQL Developer for the last 3 weeks. It's making me slightly insane.
You got to yell at Jeff about that. Oh, I bet his ears are burning. No, SQL Developer has come a long way. The installation, and Jeff will tell you, I'm the one who rarely uses SQL Developer. I'm a command line person outside of Oracle Enterprise Manager, and even then I'm using the command line interface. Oracle has the Oracle database. I love the Oracle database. I'm not so keen on the Oracle Cloud, and that they've really had to split those teams up to take on both initiatives inside Oracle has been, as far as I'm concerned, it harms Oracle. The Oracle database itself, the tools, when we start talking about performance data, SQL Server, Azure SQL, you don't have the AWR, and it hurts you. I just had this conversation with Tracy Porgiono. I sent her an AWR report. She says, we need this. Yes, you do. AWR report it's the God. It's awesome. I mean, it tells me everything. I can use it for performance optimization. I can use it for sizing. I can use it for identifying health checks. I mean, you got to go to Paul Randall's scripts to do that here. To have that script repository, not just the data repository, is fantastic. And the query store is incredible. I mean, for me, I'm still back to DMVs. But, the DMVs have value that I don't find as much in Query Store unless I'm trying to do performance tuning uniquely to that SQL. And even with my Oracle arena, remember, I came to Microsoft to start doing more with Azure SQL and SQL Server, and it was 4 months in, and they found out I knew Oracle, and it just went downhill. There was no escape for me at that point. But, I'm still doing a lot with that. I'm starting to do more with Postgres now, and we recognize the tool set differences that the AWR, it was written by the gods of Oracle, and they did a phenomenal job. I mean, I can't give enough credit to, Graham Wood and Yuri Shaft and JB, and these guys just did a fantastic job on this product, that it has its own background processes and its own memory buffer, and it's reading one way and writing to the other, and the repository writes every 10 samples of ash to it. It's fantastic. And just the reports themselves are incredible. I just wish we had something like that on the other side. Now, SQL Developer, understand that recently they changed so that he was pulling from AWR. So, I mean, Jeff is pulling from AWR data to do the performance there, which is fantastic. And he did that 3 years ago, started rewriting it.
Yeah.
So it's been a while he's been pulling from there, and that's the right place.
Yeah. Well, you're there at Microsoft, so hopefully you can influence some of the SQL guys with some of the best things in Oracle, and then maybe vice versa. We can take some of the great things in SQL Server and send them over to Oracle as well.
Rowan will tell you I already corner him every year at Summit, Rowan Kumar.
There you go. Good, good, good. That's good to hear.
I want an AWR for SQL. No, it's all good. Well, thank you so much, everyone. It was awesome. I know it's like 11:59 and I have to go and speak at another session somewhere else. So thank you again. Have a great day. And I hope it was beneficial.